Welcome everyone. Today we have our Chapter 18 video on confidence intervals for a single proportion. So let's just say to open this up, we are interested in the proportion of all teenagers who wake up on a Monday morning and contemplate taking a sick day. Well, we know that this is not very realistic to survey every single teenager in the United States or even North Dakota or Fargo. And also, if we take a sample of teens, we cannot ensure that that sample is totally representative of our entire population. So this is where the idea of confidence intervals comes in, where we take information from a sample, we create a range of values that we think the actual percentage of all teens would be within. So let's just say that we take 500 teens, and of those 500 teens, 190 of them consider taking a sick day each Monday morning. Okay, so from our sample, 190 out of 500, that is 38%. We cannot say that all teens, 38% of all teens, want to take a sick day on Monday simply from one sample. Okay. However, what we can do from that sample, that 38%, is form what's called a confidence interval around the 38%, and that will tell us about what we think our estimate of the actual proportion would be. Okay. In order to do this first, though, let's talk about standard error. So because we only have access to a sample of our population, not the whole population, we don't actually know what the standard deviation of our population is. So this is where we have to estimate standard deviation, and we call that standard error, okay? Luckily for us, the formula for it is very straightforward. If we look here, from our sample, it is the square root of p hat times 1 minus p hat divided by n. So p hat, that is just our sample proportion. So for us, it was 38%. That's what I filled in here. 1 minus p hat, also known as q hat, that is 0.62 in this case. 100% minus 38% is 62%. And then we just have to divide by n, which is our sample size. For our purpose, it was 500. Okay. So for this specific example, we would get a standard error of 0.000471. So if you remember, we've not talked about the normal curve just yet, but we will in a moment. We had, when we have a normal curve, that 68% of our data will fall within one standard deviation of the mean, 95% will be within 2 standard deviations, and 99.7 will be within 3 standard deviations. Just know that we have that same idea when it comes to standard error, okay? So 68% of all samples will have a sample proportion within 1 standard error, 95% will have it within 2 standard errors, and 99.7 will have it within 3 standard errors. And we're going to elaborate on this more in a bit. So in that same vein, if we talk about what's referred to as a 68% confidence interval, what that means is we want to find an interval so that if we do samples of 500 over and over and over again, 68% of the time, we will capture that actual percent of teens who want to take a sick day, okay? So 68% really isn't that precise, but I think that just makes sense as a logical starting point because we know about 68% of our data will be within 1 standard error of our sample proportion, okay? So to make a confidence interval, we found that standard error before. We could say that we are 68% confident that the true proportion of teens, or the actual proportion of teens who contemplate calling in sick on Mondays, is between p hat minus that standard error and p hat plus that standard error, okay? So our p hat, remember that was 38%. If we subtract our standard error and add our standard error, that gives us an interval of 37.95% up to 38.04%, okay? So 68% confidence, that would be our range of values for that one. Likewise, if we think about the 68-95% portion of that rule, we could say that 95% of our sample proportions will be within 2 standard errors of our sample proportion, okay? So you kind of see a pattern here. As our confidence level increases, so does the size of our interval. So now that we've talked about standard error, that's just the part under the radical, the square root of p hat, 1 minus p hat divided by n. We can now talk about what's called margin of error, okay? So if you remember, when we had the 95% confidence level, we talked about having within two standard errors of whatever our sample proportion was. When we combine the standard error, so that formula for the square root p hat, 1 minus p hat over n, and we also include how many standard errors we want to be within, that's what we refer to as our margin of error, okay? And if you think about the plus minus portion of this formula, it is the piece that we're going to add and subtract from our sample proportion, okay? So in general, our confidence interval formula will be our point estimate for our purposes now. That's going to be our sample proportion, plus or minus our margin of error, okay? And like I said before, the more confident we want to be, the larger our margin of error needs to be. So expanding that idea to our 3 standard deviations, or standard errors for our purposes now, we could say with 99.7% confidence that the true proportion would be within 3 standard errors of our sample proportion. So like I said, if we want to increase our confidence level, to be more certain that we are capturing that actual percentage or proportion that we're looking for, we end up being less precise, meaning we have a wider range of values that we're estimating in between. So because of this, every confidence interval, we have to balance certainty and precision, okay? So we want to be certain that we're actually capturing that true proportion, but we don't want to be so broad that we have a range from like 0 to 100%, because that's not very useful. Even from 25 to 75%, that's not very useful. So we want it to be a small enough interval where we have a pretty good idea of what that might be, but not so small that we're not going to capture it altogether. Okay. Luckily for us, there are some common confidence interval levels that we use, and it's kind of the same rotation of procedures every single time. Like I said, most of the time we're either going to use a 90% confidence interval, 95% confidence interval, or 99% confidence interval. Those are kind of the 3 main ones, but just know that you could use any percentage that you'd like. So our next concept in that formula for an entire confidence interval, we're almost done here, is the idea of a critical value. So with that 68, 95, 99.7 rule, when I say that 95% of our data is within 2 standard errors of our mean or the average, that 2 standard errors is actually an estimate. And what a critical value is it tells us precisely how many standard errors from the mean we would expect it to be, okay? So for example, for a 95% confidence interval, instead of being within 2 standard errors of the mean, it's actually 1.96, okay? So we're gonna see that in general, it's really, really close to what we've been using, but using technology, we can actually be really precise with how many standard errors it would be, okay? So for any confidence level, whether it's 90%, 95%, 99%, this Z star value or the critical value is going to be dependent on that confidence level, okay? And I'm going to show you here in a moment, putting all this together, what that looks like. So as another example, for a 90% confidence interval, our critical value is 1.645, okay? So no matter what the situation is, if you're looking for a 90% confidence interval, that critical value is going to be 1.645. In other words, it would be within 1.645 standard deviations or standard errors of our expected value. So just like we saw in class, before you create a confidence interval, we can't just assume, hey, we've got this normal curve, we're going to use it. This is where you first have to check some conditions, okay? The first one is the randomization condition. So make sure that the sample you've obtained to get your p hat is actually a random sample. Then we have the 10% condition. This just makes sure that our sample size isn't too big. So our sample size, or n, cannot be more than 10% of our population size. And then the success failure condition, this makes sure that our sample size isn't too small, okay? So within a single sample, we need at least 10 what are called successes, or in our case, that would be 10 people who want to sleep in on Mondays, and we need at least 10 failures, so 10 people who do not want to do not want to take a day off, okay? So if these three conditions are met, you are clear, you're good to go on a confidence interval. Finally, putting all of this together, if we have all the conditions met, we want to make our confidence interval, then this is our formula for the confidence interval. All right, let me outline each piece of it. We are going to take our p hat. Again, that is our percentage from our sample. So 38% is what we found in our previous example about sleeping in on Mondays. We're going to take that percentage plus or minus, and this whole side is what we call the margin of error. Okay. Just under the radical here, this part here, that is called our standard error, but as soon as we include the z star value, all of this together is called our margin of error. That's what we're adding and subtracting, okay? So we're going to take that p hat value plus or minus z star. I'm going to show you that in class, but that is solely dependent on our confidence level, okay? So it's going to be the same for a 95% confidence interval. Or if we had a 90% confidence interval, there's a z star value for that as well. And then we just have to take that times our standard error, which p hat, square root of p hat, is the same thing as what we saw over here, so that 38%, times q hat, or 1 minus p hat, in our case that would be 62%, divided by the square root of n. So by taking that p hat value plus or minus our margin of error, we come up with an interval of values that we think our true proportion is within. So finally, a final comment on this is if you want to find a confidence interval, but I've not given you what the p hat value is or what our sample proportion is, you can just assume that that's going to be 0.5 or 50%. Typically, we would want to have an actual recorded p hat value, but if I don't give that to you, you can just assume it's 50%. So hopefully you get the basics of this. When you guys come to class tomorrow, we're going to talk all about different ways that we can do these. I'm going to actually walk through a couple of these with you. You're going to see that it's not very complicated. It's just a direct application of what we saw in sampling distributions, and the results and the outcomes of confidence intervals are extremely useful and beneficial to us.